Thank you so much.
Hello, hello, everyone.
It's an honor to be here with you all today. Otávio, are you excited to discuss about how we can help them improving, how we can help them improving their applications by understanding frequent Java problems that happen and they might not even know when they are using persistent solutions like databases?
Oh, yeah, it's a nightmare, right? So it's hard to handle a lot of stuff like this, especially database, persistence, application, architecture, performance, isolations, business, and the whole world is happening.
Right. So while I was sharing my screen, I would like to quickly introduce ourselves. So please meet Otávio Santana. He works closely to help build in the future of Java. So he's part of several foundations, including the Eclipse Foundation, helping to lead and create new specifications for Jakarta EE, for example. So he's directly involved with that. He writes books, he likes to give talks, and many more. So welcome, Otávio Santana, our distinguished engineer. It's great to be here with you, Otávio, talking about this as well.
Oh, thank you. But today I'm not a star. With you guys, we have Karina Varela, who is Principal Technical Marketing Manager at Red Hat. Red Hat is the biggest open source company in the world. She drives several communities that includes the key, knowledge is everything. Also, she's an instructor, she's a writer. She tweets and shares a lot of things about software architecture, persistence, CDC, and so on. My advice for you guys is follow her on Twitter. Karina?
Follow us. And by the way, Otávio, last quick test. Do you hear any echo when you're speaking?
No.
Awesome.
No.
So guys,
no.
one thing I would like to say is that I love seeing some familiar faces here. So hey, Oliver, we've met recently in a conference, so it's great to see you here. Many others as well. And so let's get started finally, because we have a lot to share. And get ready, because it's not going to be just slides. We are going to show you stuff in action with live coding. And the way we like to give talks is to actually have you interacting whenever you need. So if you have questions, you can choose to either drop them on the chat. We are following it as we give the talk. Also, if you prefer to open the mic, just, I don't know, raise the hand, say something here. We will give you space. So share any questions as we go. Yeah, so it's time to upgrade your persistence skills. And we are not talking exclusively about how to improve your JPA persistence skills with relational databases or with NoSQL databases. So there are so many ways to improve, to store our data. So we are going to cover a lot of information here, including why do we even have databases? We are going to cover this real quick. We are also going to see some of the challenges we face when storing data for our stateful applications. Why in-memory persistence solutions could be helpful, and why are they more performant than other solutions out there in the market? Also, what does this has to do with MicroProfile and Jakarta EE at the end of the day? Okay, so Otávio, tell me, you love history. Where does this story come from? Why do we have databases?
Yes, I usually put some history facts, especially because my slogan is about, okay, right now we are writing history with software, right? And the database is not new. It's not a new stuff. The main goal to database is to endure knowledge throughout the humanity. So if you think about history, the first database were temples, caves, and especially because the information was were there, right? So why do you need database? Because we need to have more efficiency to handle with data, to move that to knowledge, to apply that as best situation as possible. Of course, today is not to talk about history, but modern application. When you talk about modern application, we talk about stateless application, right? And stateless, we need to put a state in some place that might be the database. And have much more information, backups, and things like that, right? However, the database is so important, but we usually don't talk much about it. So if you compare the number of articles, books, and so on to software engineer, we have much more articles around API design than persistence design, right? So we have clean code, DDD, and a lot of stuff like that. However, we have even refactoring, but we don't have refactoring database book. We have just a few maturity models.
Yeah, and the type of information we are going to discuss today, even if we are going to cover some how-to topics, the most critical piece here is for you, senior developers, architects, to understand the several options you have out there. And like Otavio mentioned, there are many best practices, information on how we can architect our solutions for cloud native modern deployment strategies, and how we can create our applications, and so on and so forth. But we end up forgetting about database, right? How we can improve this piece. And this is very frequently the bottleneck of applications. When it gets to production, when things get real and data starts coming in, people start to feel when the impacts of their diligence of not making the right decisions regarding persistence. And why is it so hard to make decisions? Man, look at so much options in database flavors out there. Just this to get started is already a huge challenge. Other than that, do we have maturity models, Otavio, for persistence adoption and implementation?
Unfortunately, just a few. And no one very popular, like, for example, if you want to move out to microservice, you might know about Richardson model or the glory of REST. And we don't have anything so popular in the database. The exception might be the normalization process. If you use a strong imagination, put that closer to a maturity model where you're gonna model your model to get more consistency and avoid duplicated information through normalization. Okay.
Over my 8 years of consultancy within customers of different sectors, this is what I see, Otavio. Either they have the developer who map their objects with ORM like Hibernate, and then automatically generates the data scheme, and that's it. And then DPAs complain about it, or they have the DPAs configuring stuff that is not easily usable from our Java applications. So it's very complex to understand how to do this stuff. So
yeah, especially because, I mean, when you talk about language, we have a good number of language, but database flavors, as you showed, it's hard to choose one, right? Okay, I'm going to SQL. Okay, you have several flavors of SQL. So each one, MySQL, Postgres, Oracle, Microservices, SQL Server, MariaDB, or so on, Oracle. And usually when you talk about NoSQL, of course, we have a lot of, but usually when you talk about documents, we usually think about MongoDB because it's so far the most popular solution. Word column with Cassandra, key value with Redis, and graph with Neo4j. Of course, we have several options, but at least we have a kind of default standards in NoSQL. However, it's hard to do this kind of thing when you talk about SQL, for example?
Otávio, database, dealing with data is the first thing we do. And whenever we get this wrong, the costs later to fix the issues or the things we left for later on the backlog, well, they're going to be costly, they're going to be hard. And it's a challenge to maintain data that needs to evolve over time. Still today, right?
Yes. I mean, we put the model design when we usually don't know enough about the product idea, or the product idea is not mature enough. And the migration between models, the refactoring, when we talk about code, is just an ID and a PR. However, when we talk about database, it's something a little bit deeper than that. A migration, especially when we talk about migration between a database. For example, I'm using SQL and like to use MongoDB or something like that, and keep moving this data is the tough part. And that is not enough, right?
And Otávio, you were talking a lot about mapping the objects to the database and how that happens. There's a problem that has a very fancy name, by the way, if you have never heard of it. It's called the object mismatch impedance. What is this? Well, it's a conversion. It's something that has to happen whenever we map Java objects that are created with oriented programming language to relational database, like to tables, things that does not follow the same paradigms, does not support the same features. Same for NoSQL. We do not have a one-to-one feature support on oriented programming languages and NoSQL or SQL databases, relational databases. So what are these types of things I'm talking about? Well, examples of these are polymorphism, encapsulation, different types. Not all Java types are supported. For example, in the database types, every time we need to have a conversion happening there. Have you ever stopped to think about this? These conversions that happen there, they cost us time, processing, resources. Actually, up to 90% of the operations have to go through these types of added latency, as we are going to see in a second. But before that, we want you to understand what is the mismatch impedance and why does it impact you in your stateful applications today.
Yes, and the whole point right now is, okay, to do a good design, we probably need to read when we make a type by Multifolder, where when you need to create any kind of complex object that has several rules to be there. For example, an email type or a national document type, like security number. It's a type, and the database does not have support to any kind of thing like that. So I need to do this kind of conversion to and from database. It doesn't matter if you're going to use a SQL or relational database or NoSQL database. The whole point is, as Karina said, there are several things that we as Java developer are familiar and make sense to use and explore as code design, but it won't have support in database. Therefore, I need to put a complexity there. Okay, I'm using Hibernate. It doesn't matter. Somebody is handle that complexity and that conversion for you, and that has a cost. That has a trade-off.
Exactly. That is exactly my thought, what I was thinking here. The developers who are not on the level of coding frameworks yet, they think that this is not a problem that happens with me. Well, this happens with ORMs like Hibernate and others, like Otávio is saying. So even if you don't understand the technical details on how it does this conversion, this translation, it does happen.
Yes, and as Karina said, it's a long time to do the conversion between a database and the application itself. So takes here, for example, we have our application and microservice or whatever. We have our Java objects that we handle with. If you do a good code sign, we need to make that closer to the business. So empty, this kind of thing like this. And then we have our framework. It doesn't matter to do that conversion, especially because when we talk about code design, Hibernate or Eclipse link do need to take these Java types and convert to JDBC type, and then the JDBC type will connect with relational database.
Even if you are using cache, because people will say right on time, but I use cache, I don't need to use that. It's also part of the layers in this image.
Yes, I mean, even with cache, one time need to convert that. One time need to take the object and insert in database or read from the database.
Otávio, when you're talking about searching on the database, notice that we are going somewhere else. We are going to have this added time on the network, whatever it is, to reach out to this other tool that will have its own processing that then can return our data or do the operation we are requesting.
Yes, and we have a throughput, we have a confirmation, we have several steps until get my information to or from a database, and also the paradigms conversion. So I'm using object, I need to convert to a database, or I'm using database, I need to convert that to an object. I mean, the style, the relationship, or something like this. And what happened if we decided to eliminate that layer? Therefore, instead of have Hibernate or Eclipse uplink or any kind of conversion, my graph database structure, my structure is already my database, as you can see here. So I have my microservice, I have my graph, my structure with my information, and then I have my information here where it will be replicated to any data target, right? Because I need to make that scalable. So I will save 90% of the query.
Yeah, we have removed like several layers here. So in this scenario, are you saying that I don't need to do the conversion and that I will get the memories, the object from any memory persistence if the data is in there? Are we talking about cache? Is that what this is?
No, it's a solution. It's a database solution to make it possible.
Okay. So this is interesting. So let's talk about how we can actually do this, eliminate the problem of mismatch impedance, all the latency that it brings to us, all these extra operations, the added complexity in data mapping to relational tables or to NoSQL databases. Also, just abstract all these problems that we have when we are creating applications that need to store data. And in order to do that, we are going to talk about Microstream that brings to us a way to do ultra fast in-memory data processing with pure Java. There are so many benefits of those. I had to pick and choose some to share with you. And before you think this is just a slide, we are going to be able to see this in action in a couple of minutes, actually. And this is very different from what we have seen so far, because you might think, well, we do have other in-memory solutions out there, but not exactly like Microstream, because with Microstream, we will just be using a very, very lightweight library within our application, so we can have this storage being embedded in our solution, or having a data store as a target to save the data. Where, Karina? We're going to see. Also, we can use just pure Java. We don't have to worry at all about our data objects other than doing good practices for Java coding. So we acquire good practices, we do our DDD, we use our Java and oriented programming capabilities, whatever we need, without having to worry about it. And we will understand how all of this is actually possible. This is very interesting, right, Otavio? It's like quite a surprising number. 1,000 times? This looks like marketing to me, definitely.
Yes.
And I am a marketing person, so I know when I see it. Is this really true? Because it just looks weird. How can that happen?
Yeah, especially because Microstream explores the memory information. So, and as I mentioned before, with JPA or any conversion mapping, it doesn't matter the language itself, I need to do the communication between my paradigm and my database paradigm. The idea is to reduce tests using this solution. As you can see here, I'm doing a query by books, by price, greater and retail price less than. So I'm using the between.
This is just Java streams, normal Java streams.
Yes.
It's no, like, no, I don't have to learn any new language. That's awesome.
Yes, I'm using a pure Java structure, and the solution will handle the information for me. I don't need to care about anything. I don't need to learn a new
API,
a new database API, a new database good practice, especially because Microstream will handle the time details for me. As a developer, it's awesome, right? Because, okay, if I do a good code design, Microstream will take care of anything else. And we already know, right? So if you're able to only focus on the code design, it's pretty hard. So the idea is to reduce and focus more on the business side.
Exactly. So awesome. We can use Java, we can save data in memory. But data in memory, well, is it actually persistent? Yeah, so that's why we have different options to store the data. By default, we have local file system. There are several adapters, as you can see. Since Microstream is open source, we can also send new adapters or check out what's coming, send issues on GitHub, contribute. I love open source. Remember that. So yeah, go ahead, Otavio.
And that's a beauty, right? Because, okay, Otavio, but I don't trust my information in memory, of course. You are able to translate the Microstream information through several data target solutions. So, okay, I want to use a relational database because my company has support to a specific vendor, or my team has information about this. I want to use NoSQL for any perspective, so we're able to. So, okay, I don't want to use the solution. I want to use object store. So you also have support for it. So you have support to object store like Oracle, Amazon S3, NoSQL, with MongoDB, Kafka, Redis, Amazon Hazelcast, or even the classic mature relational database with MySQL, PostgreSQL, SQLite, and if you want, you are able to. It's open source. Create your own connector. I mean, imagine right now I don't have any kind of thing like this. I don't have my own connector or my database connector. If I wish, I can help or contribute on this product.
Otavio, but this is awesome. I know I have a library, lightweight library, to put on my application to help me storing data in an ultra fast way. Nice. But let's take a look at code. I'm tired of slides right now. So basically, can you explain to me about this API? What does it has that is so special about it?
What you do have here is the simplicity. So we have a store manager who will represent the manager to get the information. If you are familiar with JPA, it might be like an entity manager factory. And your entity manager will be your own structure. So as you can see here, I create my own structure, then finance in my manager. So I did a set hood where the structure that I want to put is whatever I want. Then I add an item. And finally, I persist this information.
This is cool. We are talking about graphs. We are dealing with graphs then. We are handling the whole object graph at once. Is that it? Will you be able to show that on the live coding? Because I want people to stay here and then look at it. Awesome. So let me move forward, because you might be thinking, does this actually, can I actually use this wherever I work or with my favorite framework? Yes, this is the beauty of specifications. Is specifications for the win. So look at this. CDI. With CDI, we are able to use several servers out there in runtime in execution environments. So you will see that Microstream is powered by CDI. That means that whichever solutions that are compatible with MicroProfile or Jakarta EE, you should be able to use it without any issues. That's the beauty of using things based on specifications. You are not learning something that you will have a vendor lock-in, right? You're just free to do whatever you use, to use whichever data targets that better fits your company strategy. So look here, we have Elidon, Payara, we have Wildfly, JBoss, Apache Tommy, Open Liberty, and several others. So with that,
yes, that's what I mean about water, right? Right ons, run anywhere. And with the integration with CDI, we're able to do that. So everything that has support to CDI on specification words like MicroProfile, it doesn't matter the implementation, or the category, it doesn't matter the implementation, might have access to Microstream.
Otávio, so I have an idea. Why don't we do like with the most basic scenario ever on the Java context, and then we do everything we need with Java SE only. If we have the time, we can even show that we can only copy and paste the CDI code, the MicroProfile code, the Microstream code that is based on CDI, and it would work with Payara, with Elidon that are MicroProfile. It would work with Jakarta EE servers. We could see it working everywhere without it changing any code. So what do you think of us starting to show this coding right now? Let's have some fun.
Oh, yeah, let's have some fun. So please, let's share my screen. Right now, you might see my, no, you, yes, you. Can you see my screen?
Yes.
So can you see my ID, right?
Yes.
So guys, basically the idea here is to create my structure with Microstream. I'm using here a plain Maven product with a couple of dependencies. I'm gonna use the weld higher than the version 2.0. Therefore, it has support to Java SE.
So this is the reference implementation for CDI, correct?
Yes, it's a reference implementation by CDI. And we have another dependency that is MicroProfile configuration. Again, we're gonna use Microstream, that is this integration here, because of that, we need two dependencies, one implementation to CDI, another implementation to MicroProfile configuration.
Otávio, can we do something around the universe? I'm really into this stuff lately. Can we do like an implementation that can handle galaxies today?
Yes, why not? So, but before, I need to define several configurations to make easier to us. I already put that also because I'm not able to memorize everything. I just put here a couple of configurations. So I will store this information in my target data, just because every time that I do an MVN clean, I'm able to, delete the information.
Okay,
But
so
anyway,
this is one thing that is important, real quick, Otavio. So remember, the default configuration is gonna be the file system, as you see here. That is, as we mentioned, we can change this to many data store targets. And this is not recommended for production, just for prototyping, testing, and so on. So let's start, Otavio, let's start.
yes, please, on production, use the several different storage targets, right? So SQL, NoSQL, storage object, something like that. So let's start with the Galaxy. As I mentioned before, we talked about the structure that we work to make it possible to work with Microstream. So
wait. Before you start, while you're typing the name of the class. So what are we going to try here? We are gonna do, we are gonna insert a full structure, change it, read it, and delete it to see how the operation works. What are we gonna do here now?
The first step is create a structure.
Okay,
so
no, but the final goals, the final goals are the, right?
The final goals is to do the create operation. So create, update, retrieve,
Perfect.
and delete.
So let's go. Create the Galaxy, please.
Okay, my Galaxy, you be my huge structure collection. To make it easier to us, what I'm gonna do, I will create just a list of celestial body. So I have my private here.
A celestial body is something that is in the galaxy. It can be a star, it can be a planet. So I think that works. We can have like the Milky Way and then have the sun and the earth as the celestial bodies. Awesome. Okay, so we have a
class.
On the celestial body, what are we gonna have in there, Otavio? Can we have the type, maybe?
The name, because we have several celestial bodies, right?
The size. We should have a Boolean as well to know if it is editable.
Oh, yeah, good point. And what else? The type, right? So
yes, can that be an enum?
Yes, indeed, it's a good idea, right? Especially because we have a limited types of celestial body.
Otavio, but wait, you are not even dealing with the structure that is going to be on the database. Shouldn't you do that first? Not with Microstream, correct? So we can worry about the things we need to worry with.
Yes, that's the beauty of Microstream. We're gonna focus on my business. Awesome. Don't be sad. I will only have two types. Okay. Star and planets. Okay. And as I mentioned before, we are able to explore the code design. For example, I'm able to do a constructor here, and that's I'm able to do my builder. Where
you can use builder without any issues with like private stuff and private attributes and so on.
Yes, you're able to explore the whole object design. If that do this kind of,
sometimes we have to use some tricky stuff out there with other frameworks. I've been through some trouble.
I will put here as a getters, the getters, you choose string here, and let's create a business rule here where a celestial body has a unique name. Nobody's able to use Earth. Just Earth is able to use Earth, and otherwise, this one will be our ID. Okay. Based on that, I will create my natural equals hash code based on that ID that we define to use. So I will choose the name as my ID. Is that okay for you, Karina? What do you think?
I'm loving it.
I'm not an expert, but okay. Right now, I have my celestial body. I have my fields. I will have to make it easier a public static celestial body builder, and then return my builder, okay? And I have my galaxy. My galaxy will do and will cover my CRUD operation. So create, retrieve, update, and finally delete. Everything you'll be, okay, thank you, IntelliJ. You'll be able, thanks for,
and again, you are not using any framework here, just Microstream. I mean, no runtimes. It's just traditional Java SE with CDI. So how can you get started? Can you create like the storage, the place where you're going to store it? How is this API? How can you get started with using the API? Please go ahead.
Okay, so right now we have the celestial body. Let's start testing the add and then return everything that they have, that we have, okay? So I have my celestial body, the body. I will do the validation. So objects, you required. So body is not new. And then I will add a body. And then, oops, it's not private. It's supposed to be a public. And then to make it easier to us, I will return get celestial names, okay? And what I'm gonna do, return buddies string. I will mapping the celestial body to name, and then I will return. I will collect, and I will split by comma. So that is it. So celestial, oops, no you. So we right now have the structure. Okay, Otavio, but what I need to do to make it storable? Basically, to make it storable, you just need one step. The storage annotation, and that is it. As you can see here right now, I'm starting to use the Microsoft integration with CDI. So I have my type with storage. Okay. To split my business, what I'm gonna do, I will create my Galaxy service. And this service will be our favorite dependency injection engine, therefore CDI. So, and how I need to use my Galaxy? We just need to have the inject, and that is it. So I have my void adds celestial body, the body, and I will call the Galaxy to add my body, and then I have my names where I will call again my celestial names. Okay, Otavio, but I need to make sure the information is there. I need to make it transactable. How can I do that? Okay, transactions is something related to database. What I do mean is I want to make sure the information will go through Microstream if without wait. I can do that using the store annotation. Our second CDI and Microstream annotation. So what did I do? I create my structure, okay? Regular Java classes with a unique annotation, that's storage. Then create my service using CDI, where I have my application scope, I inject it, and to make the action persistable, I did use the store annotation. So Java,
So
Java,
actually,
SE, 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 and choose Microstream annotation.
okay, so all you've done is creating your data model and annotating this at store annotation. So can you actually save this so we can see it working out? Because it was pretty fast, actually. I don't think we could have done it so fast with other ORMs and things like that. So what can we do on the last 10 minutes of this live session?
Oh my gosh, we left 10 minutes, right? So, okay, the next step is to use it. So
Yes,
I will,
exactly.
I'm gonna use CDI as I mentioned, so SC container. But yes, if you wish, you are able to use Microstream, MicroProfile, Jakarta, whatever you want. I have my container. If you remember, at a set, we have the storage manager, right? My manager, where if I wish, I am able to select storage manager, then do the class. And this manager here will return my root. So root, the root value, right? The root. And of course, I will inject my Galaxy service with my container. I will select my Galaxy service. And also I have my Galaxy service. Let's create the celestial body. The body, I'm gonna use my builder where I need to set up some things like the name, I guess Earth, and then the size, I have no idea, and the type, a planet, and true to is habitable. And then let's rename it to just a planet. And let's add here. So add my planet. And system out, the bodies are ta-da, service get names. So I will clean to make sure my database, if you remember, I put in targets is empty, and then I will execute where hopefully we praise with the God of demos, it will work. It should, trust me. Sometimes I do the right code in the right time, sometimes. So it will start. As you can see here, it has a CDI extension, so integration CDI extension. It's processing a storage extension, where based on that annotation here is great. The first step was to return the root. As you can see here, it's new. Why? Because if you remember, the CDI behavior is lazy, so it will only create on its required to create. So in this time, I create the planets, and then it return the Earth. Right now, I will create a star. So star that I don't have some good one.
Yes. Mm-hmm.
I have no idea about size either. The planet is a star.
So why
is habitable.
Why are you changing
Maybe
the
the
attributes
Superman.
there? Yeah, why are you changing the attributes there? So one of the questions that came up, that came through is how do we handle updates that comes from multiple microservices that are working with the same data? So maybe we would need to discuss that later to confirm I understand what you mean. But when I think about microservices, I think of services that have their independent storage when they need it, and they integrate with each other via the communication layer. It's not a good practice to access databases that does not belong to that service. So maybe I don't know, maybe I need to understand better the scenario you are thinking about. Do you have any inputs you wanna bring?
About these race conditions, any kind of thing like that, remember what I said, you're able to configure to use Microstream with any storage target. So if you're gonna use a relational database, it will convert to relational database. If you want to use with MongoDB, it will convert to MongoDB. So as any NoSQL and SQL and storage target has those different behavior, each one might have a different case to work with race condition. On relational database that has the assets where the consistency is the key on usually when you talk about even the capture. So as soon it will commit, you'll be there. However, if you work with a Redis, where we usually work with eventual persistence, you might have issues with the consistency of the information. Okay, so
and that is like
you build a database. How?
So
depends the one that
the database level, Otávio. Let us know if Otávio is cutting for everyone the audio, or is it happening just for me? So what the challenges that Otávio mentioned, they happen on the database level. But if you check on the Microstream level, you are actually able to configure the size of the memory. So if you have more memory, you can put everything in memory. If not, you can separate that. And then when you have multiple services accessing it, since it's a Java service, you do have very, 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 very high throughput. So I actually would like to even test to see by myself what would happen if I had like several services trying to update the same element to see what happened. I don't even think that would be a problem. Gotta check that though.
Yes,
Otávio,
we're talking yes, I know. So what did I do here? First, as you can see, I put my root here. And right now we do have a consistency information where I forget to implement it to a string. Doesn't matter, I just have 2 minutes. And right now we have 2 more information. So we have the sun, we have the earth. So to every time that I add an information, I'm able to choose whatever I want, okay? And that's the main point. I don't need to create my own database. I'm able to use the structure. A Microstream will handle everything for you. So how about race conditions? I want to keep focus on consistency. So let's define a consistent database such as relational database, storage target instead of a eventual database one. Okay, but I want to use eventual database. It's fine to use too, but understand, if you have multiple systems, of course, you're not able to do exactly what I did here. So don't do that in production. So use a proper connection to specific store targets. Where, by the way, Microstreams has a good documentation, so you are able to explore, understand, and go ahead. I guess I don't have time to explore, but another point is, if we had time, we will do more operation here. Every time that we need to change the structure, we have this store annotation, okay? And to anything else, just to read, we don't need to put any kind of information. We have several features to avoid to handle with a huge amount of memory registration, like the lazy, to make it possible. So I will stop sharing my screen, Karina. So
All right. So we had so much to share today, and we are glad you were here with us today. Thank you so much. If you want to learn more about Microstream, make sure you check the page, the project page. It has several information. It's pretty, several examples as well. And since it's open source, if you like contributing, feel free to jump in and contribute to it. We have a small, we will let you have a first-hand information. We might be having a champion program coming soon for those who are experts with persistence handling, data handling, and fast persistence solutions. So if you are into that, you might want to stay up to date with the news that we are going to share pretty soon on the upcoming months. So make sure you check Microstream. Let's stay connected. If you're into Java, architectural solution, and advanced recommendations for applications, please follow Otavio, follow me. And if you want to learn more about what Otavio was doing with CDI, we had a small workshop that is available in this page. So thank you so much for attending. It was great to be here with you today. I hope you.
We have one question. I don't know if you have enough time to answer that question. Jurvi, how does the stored data look in the relational database? Are the objects stored as a binary? Yes, Microstream does a serialization process. They are still working on it, but what I do know, and I believe it's working right now, is a binary, and it might have a complexity to maintain this. Yes, it does, but who will handle that will be the Microstream product itself. Okay, but I want to see, like I see the relational database. That's a trade-off, right? So binary has the benefits to be faster. However, usually it's hard to read and hard to, I mean, it's a software in architecture stuff. So you're not able to have the wonderful words the whole time.
The good thing is you don't need to do the migration directly on the database. You should have also APIs directly with Microsoft.